Welcome to One Chemistry. We are discussing organic chemistry concepts. In this video, we will see what is anti-aromaticity. It's an aromaticity concept. We will discuss through Huckel rule and understand it through 24 fully solved examples. Stay tuned. What we will discuss? We discuss the library of molecule, how it is anti-aromatic, and we will solve this by step. Totally 24 of them. Make use of it. What is inside this video? First, we will see what is anti-aromaticity and Huckel rule and step-by-step procedure for to identify the anti-aromaticity and examples, anti-aromatic compounds and common errors and tricky question and library of compounds. The library help you to establish your own understanding. More importantly, we are going to solve 24 examples from various examinations. It will be very interesting. Stay tuned. Before getting into the detail, we should know the basics. Basics is Huckel's rule as well as aromaticity. What is Huckel rule? Huckel rule is all about pi electrons. You should count the pi electron and you should know the planarity of the compound, then cyclic nature, conjugation in the compound, and through that we will identify the stability. Our focus here is anti-aromatic, but better you know all the aromaticity. There are 5 types. Aromatic means 4 and 2 pi electron. Anti-aromatic, that is our interest, 4 and pi electron. Non-aromatic means non-planar compound. Homoaromatic means it's an aromatic compound with artificial conjugation, not natural conjugation. Quasi-aromatic means conjugation with the charge. I recommend you to memorize this table. It will help you to solve all the problem. Here you should memorize that anti-aromatic means 4 and pi electron. Planar should be cyclic and conjugated. It creates instability in the system. How to find anti-aromatic compound? First you check the planarity, whether the compound is planar or not. Then check the conjugation. Conjugation means you should find whether it has alternative single and double bond or not. Then count the pi electron. One double bond is actually a 2 pi electron. Then check it is a multiples of 4, that is 0, 4, 8, 12 and 60 and so on. Then you can conclude that it is anti-aromatic compound. Then we will see basics. Charges provide the conjugation. By looking at the plain side, you may think charged compounds are not conjugated. But if the charges in conjugation with single and double bond mean it is also a conjugated compound, charges help you to delocalization. The charge can be either positive or negative. Both help for delocalization. Here is on cyclopentadiene with cation, cyclopropene with anion. Both are cyclic compound, conjugated. Here you should know it is conjugated. Avoid the confusion that it is not conjugated. It is conjugated. Charge travels. Then next basics. Charges you should count electron or not. If it is a positive charge, it contributes 0 electron. If it is the negative charge, it contributes 2 electron. Positive means 0, negative means 2 electron. Here I shown the example. Cyclopentadienyl cation, 4 pi electron conjugated. It is the anti-aromatic compound. Positive charge count as pi electron. That's why it is 4 pi. Then negative charge. Negative charge you should count as 2 pi electron. Here cyclopropenyl anion is given. Anion you should count as 2 pi. So totally 4 pi. It is also anti-aromatic. So positive charge count the 0 electron. Negative charge count the 2 pi electron. Then very important basic, empty orbital. Empty orbital, you should consider it like cation. Why? Because it provides the space for delocalization. So don't confuse that it is not delocalized. Here boron is there. Boron has empty p orbital. That's why it's called Lewis acid. The boron p orbital provide the conjugation, so act like cation. So the compound is anti-aromatic. Blind side you may commit a mistake, but empty p orbital help for the delocalization. Then next important basics, carbonyl carbon can act as a delocalized carbon. Why? Because oxygen is electronegative, pull the electron cloud towards itself. So carbon has partial positive charge. So what will happen? It is like cation. Cation can help for delocalization, provide the conjugation. If you look at it, here I given cyclopentadiene. Carbonyl provide the partial positive charge. For the understanding, I written as full charge. Then it goes delocalization, provide the conjugation. So the compound is not non-aromatic, it is the anti-aromatic due to the delocalization. Then very simple one, the triple bond help for conjugation or not? Yes, triple bond help for the conjugation. It is also the pi bond. It is also help for the conjugation. You may think that it is a sp carbon, linear, it don't participate in conjugation. Reality, one pi bond participate. It is the conjugated compound. Then very confusing basics. Triple bond, how many electrons you should count? Triple bond is formed from 2 pi bonds. So you may think that it is 4 pi, but only 2 pi. How? Because the triple bond is formed from perpendicular p orbital. So one p orbital parallel to the pi electron cloud, another is perpendicular to the electron cloud. So only 2 electron participate, other 2 electron don't participate. Here I given the compound with 3 pi bonds, 3 triple bonds. So if you count it, it is 12 pi, not the 18 pi electron. Then very interesting basics, check the planarity. Here a given cyclooctatetraene, it is also called as COT. By looking at the plane side on paper, you may think it is anti-aromatic compound because it is cyclic, it has conjugated double bond and 8 pi electron look like planar. So you may think it is anti-aromatic compound, but in real structure it is a dove shape. The structure is bent structure. It is not planar. So no conjugation, no planarity. It's a non-aromatic compound, not the anti-aromatic compound. Then the next basics. Here you have fused compound. By looking at it, you may think non-aromatic, non-planar. Why? Because sp3 carbon is tetrahedral, not planar. The structure contained inside non-planar CH2 carbon, so it should be non-aromatic. But in real structure, the CH2 will be out of the plane. It don't disturb the aromaticity, so it is anti-aromatic because it has 12 pi electron, conjugated, planar, anti-aromatic. So you should know the geometry before getting into the full detail. Then we are going to see important section, solved example. We are going to solve 24 anti-aromatic compound with step-by-step explanation. Why so many? Because problems are best way to learn. It will give different perspective and complete understanding. So stay tuned. Let us see the first example. Here you have two 7-member system. It is fused one connected through 2 carbons. We have to find aromatic or not. Here the system looks cyclic. So let us analyze the pi bond. There are 6 pi bonds. So 12 pi electron. Charge is 0. So don't bother. Lone pair is also not there. So 0. So if you look at the Huckel rule, 12 mean 4n system where n equals 3. So 4 multiplied by 3 gives 12 pi electron. So the system is cyclic, conjugated. 4n electron mean it is the anti-aromatic compound. Then the next example, here you have cyclooctatetraene, both sides connected with fused diene. It is the fused compound. You should find the compound is aromatic or not. Here the system is fused system. First let us analyze the pi electron. There are the 8 pi bonds. First ring 2 pi bonds, middle ring 4 pi bonds, terminal ring 2 pi bonds. So totally 8 pi bonds means 16 pi electron. Charge is not there, so 0. Lone pair also not there, so 0. So if you look at it, it's a 4n system where n equals 4. 4 multiplied by 4, 16 pi electron. The system is definitely conjugated. Planarity also there. So 4n conjugated. Planar mean it is anti-aromatic compound. Then the next example. Here you have cyclopentane system with one boron as the heteroatom, diene in conjugation. You should find compound is aromatic or not. Here you have boron. By looking at the plain side, you might think that it's a non-aromatic compound because there is no conjugation. But if you redraw with p orbital, you can clearly see that it can act as a cation. So empty p orbital like cation provide the conjugation. So let us analyze the pi bond. 2 pi bonds are there, 4. Charge is not there. Here it is like cation, so charge is 0. Lone pair also not there, so 0. So totally 4n pi electron where n equals 1. 4 multiplied by 1, 4 pi electron. So it is the 4n system. The compound is conjugated because empty orbital help the delocalization. Compound is definitely planar. So the system is 4n system conjugated. Planar mean it is the anti-aromatic compound. Then the next example. Here you have cyclobutadiene. You should find it is aromatic or not. The compound is simple, straightforward. It is the ideal system for anti-aromaticity. Let us count the 5 electron first. It has 2 pi bonds, so 4 pi electron, and charge is 0. Lone pair also 0, so 0 pi electron. So it is the 4n system where n equals 1, totally 4 pi electron. So 4n system, conjugation also there, alternative single and double bond, and planarity also there. So the compound is anti-aromatic compound. Then the next example. Here you have connected system. One side 7-member ring, another side also 7-member ring. In the middle you have CH2. CH2 is sp3 hybridized carbon. So you should find the given compound is aromatic or not. If you look at the compound with proper geometry, you will understand that sp3 carbon go out of the plane. Actually, both the rings are in planar. CH2 go out of the plane, maintain the non-planarity. sp2 carbon is planar. sp3 carbon is tetrahedral, so it go out of the plane. So we start from fundamental. We count the pi electron. So totally 6 pi bonds. So 12 pi electron. No charge is there. Lone pair also not there. So 0. So it is the 4n system where n equals 3. 4 multiplied by 3, 12 pi electron. So it is the 4n system. Conjugation definitely there because CH2 go out of the plane. Given the space for conjugation, definitely the rings are planar. So it is yes. So 4n pi electron conjugation. Planar mean anti-aromatic. Then the next example, here benzene fused with 8-member ring, 2 alkyne, 1 alkene is there in the 8-member ring. You should find given compound is aromatic or not. Here we start from fundamental, but our question is how many electron triple bond contribute. Because you have triple bond, it can provide 4 pi electron, but only 2 participate in the delocalization. So triple bond contribute 2 pi electron, not 4 pi electron. So if you count it, 2 pi bonds 4 and 4 pi bonds, totally 6 pi bond. So 12 pi electron, no charge is there. Lone pair also not there. So it is the 4n system where n equals 3. So it is the 12 pi system. Finally, 4n system conjugation. Planar mean it is the anti-aromatic compound. Then the next example. Here you have cyclic system with 6 pi bond. You should find given compound is aromatic or not. Here we start from counting the pi electron, totally 6 pi bond, so 12 pi electron, charge is not there, lone pair also not there, so totally 12 pi electron mean it is the 4n system where n equals 3, 4 multiplied by 3 gives 12 pi electron. The system is conjugated, alternative single and double bond, planarity also there. By the Huckel rule, 4n conjugation, planar mean anti-aromatic compound. Then the next example, here you have fused system, 6-member, 4-member, 6-member system with conjugated double bond. You should find the compound is aromatic or not. As usual, we start from pi electron counting. Here you have 6 pi bonds mean 12 pi electron. Charge is not there. Lone pair also not there. So 12 pi electron mean it's a 4n system where n equals 3. So totally 12 pi electron. The system is definitely conjugated, alternative single and double bond, and planarity also there, cyclic in nature. According to the Huckel rule, 4n system conjugated, planar mean the given compound is anti-aromatic. Then the next example, here you have fused pentane system, 2 pentane molecule fused through 2 carbons. You have 4 double bonds. You should find the compound is aromatic or not. We start from counting the pi electron, totally 4 pi bonds mean, so totally count the pi electron mean, so totally 8 pi electron. It is the 4n system where n equals to 4 multiplied by 2 gives 8 pi electron. The system in conjugation, alternative single and double bond. The compound is cyclic and planarity also there. According to the Huckel rule, 4n system conjugation, planar mean the given compound is anti-aromatic. Then the next example, here they given macrocyclic system. It is an aniline with 16 carbon with double bonds. You should find the given compound is aromatic or not. We analyze the aromaticity by counting the pi electron. So totally 8 pi bonds are there. So 16 pi electron, no charge is there, no lone pair is there. So totally 6 pi electron. So it is the 4n system with n equals 4. 4 multiplied by 4 gives 16 pi electron. And the system is conjugated with alternative single and double bond, and the compound is planar and cyclic. According to the Huckel rule, 4n system conjugated, the given compound is anti-aromatic. Then the next example, here you have cyclopropene with anion. You should find the given compound is aromatic or not. Here you have charges. Careful with that. Let us count the pi electron. Here you have 1 pi bond. So 2 pi electron. Charge you have -1, which is 2 pi electron, and lone pair is 0. So totally 4 pi electron mean it is the 4n system with n equals 1. 4 multiplied by 1 gives 4. So 4n system. Further, the compound is conjugated because the anion provide the conjugation and definitely planar. So 4n system conjugation. Planar mean according to the Huckel rule, it is the anti-aromatic compound. Then the next example. Here you have cyclopentadienyl cation. You should find the compound is aromatic or not. Here you have charges, so careful while calculating electron. Let us start from counting the pi electron. Here you have 2 pi bonds, so 4 pi electron. Charge is +1, but cation don't contribute pi electron. Lone pair is 0, so totally 4 pi electron. It is the 4n system with n equals 1. 4 multiplied by 1 gives 4 pi electron, so it is the 4n system. Further, the system is conjugated. It has alternative single and double bond, and cation also continue the conjugation, and compound is planar. So 4n system conjugated. Planar mean according to the Huckel rule, it is the anti-aromatic compound. Then the next example. Here you have cyclopentadienone. You should find the compound is aromatic or not. By looking at the plain side, you may think that it's non-conjugated, non-aromatic compound, but reality carbon possesses partial positive charge. We can take it as a full charge. It can help for the conjugation. So we can start the pi electron counting. It has 2 pi bonds. We should not count carbonyl pi bond, only the conjugated pi bonds. So 4 pi electron. Charge is delta plus. It don't contribute any electron, so 0 pi. Lone pair also not there, so 0. So totally 4 pi electron mean it is the 4n system where n equals 1. 4 multiplied by 1 gives 4. It gives 4n system. The compound is conjugated. Partial positive charge help for the delocalization. So it is the 4n system. Further, the compound is planar because all are sp2 carbon. It is cyclic planar compound. Finally, it is 4n system conjugated. Planar mean according to the Huckel rule, it is anti-aromatic compound. Then the next example. Here you have cyclobutene with cation and anion. You should find the compound is aromatic or not. Here you have interesting case, cation and anion in the same system. Both cation and anion contribute to the delocalization and assist the delocalization. Both anion and cation help the delocalization. So conjugation and delocalization not an issue. We start from counting the pi electron. Here you have 1 pi bond, so 2 pi electron. Charge you have -1 and +1. Plus we don't calculate, minus we calculate, so 2 pi electron. The lone pair is not there, so 0. So totally 4 pi electron mean 4n system where n equals 1. And the system is conjugated because cation and anion provide the conjugation, and it is definitely planar. So 4n system conjugated planar. According to the Huckel rule, it is an anti-aromatic compound. Here you have cyclohexadiene dication. You should find the compound is aromatic or not. The system is very much interesting because you have two positive charge. Two positive charge help for the delocalization. So don't confuse with non-planarity. The compound is planar. Delocalization also there. So let us count the pi electron. There are two pi bonds. So 4 pi electron. Charge is +2. Cation don't contribute pi electron. So 0. Lone pair also not there. So 0. So it is the 4n system where n equals 1 give 4 pi electron. The conjugation definitely there because alternative single and double bond charge also in the conjugation. So it is conjugated. Further planarity also there. So 4n system conjugated. Planar mean according to the Huckel rule it is anti-aromatic compound. Then the next example, here you have cyclopentadiene with heteronitrogen. It is a pyrrole with cation. You have two pi bonds and nitrogen cation. You should find the compound is aromatic or not. Here you may think that the compound is not aromatic, but cation provide the conjugation, give the anti-aromaticity. We will go by the basics. We start from pi electron counting. Here you have two pi bonds. So totally 4 pi electron. Charge is +1. It don't contribute. So 0 pi electron. Lone pair also not there because it is taken by hydrogen. So lone pair is 0. So totally 4n system where n equals 1. And the system is conjugated. Cation provide the conjugation and planarity also there. So 4n system conjugated. Planar mean according to the Huckel rule it is the anti-aromatic compound. Then the next example. Here you have 6-member cyclic system with 2 double bond, 1 oxygen, 1 anion. You should find the given compound is aromatic or not. By looking at the blind side, you may commit a mistake, but the compound involves delocalization from anion and lone pair. Let us start from the basics. First, we will count the pi electron. We have 2 pi bonds, so totally 4 pi electron. Then you have anion, so we count 2 pi electron. Then you have 1 lone pair. For that, we should count 2 more pi electron. So totally 8 pi electron. 8 pi electron is 4n system where n equals 2. Then we look for conjugation. Definitely conjugation will be there. Lone pair and anion help for the delocalization. System is planar. Definitely delocalization and conjugation also there. Then compound involve delocalization mean it is definitely planar. So 4n system conjugation. Planar means the given compound is anti-aromatic. Then the next example. Here you have aniline with 12 carbon atom with 6 alternative pi bonds. You should find the compound is aromatic or not. Here we will start from basics. The compound has 6 pi bonds, so 12 pi electrons. The charge is not there, so 0 contribution. Lone pair also not there, so 0. So totally 12 pi electron mean it is the 4n system with n equals 3. 4 multiplied by 3, 12 pi electron. The system is definitely conjugated, alternative single and double bond, and all are sp2 carbon. So planarity also there. So 4n system conjugated. Planar mean according to the Huckel rule it is an anti-aromatic compound. Then the next example. Here you have 20 carbon system with alternative single and double bond. Totally 10 pi bonds with 20 carbon. So 20 aniline system. You should find the compound is aromatic or not. The compound may look big, but we start from fundamental. We count the pi electron. Totally 10 pi bonds are there. So 20 pi electron. Charge is not there. Lone pair also not there. So 0 contribution. 20 pi electron means it is the 4n system where n equals 5. 4 multiplied by 5 gives 20 pi electron. So it is the 4n system. Conjugation also there because double bonds are alternative single and double bond and all are sp2 carbon. So it is the planar system. So 4n system conjugated. Planar mean according to the Huckel rule it is an anti-aromatic compound. Then the next example. Here you have 6 member and 5 member fused system, 4 double bond, 1 ketone. You should find the compound is aromatic or not. Here you have carbonyl in the system. Carbonyl provide the partial positive charge because of electronegative oxygen, electron cloud towards oxygen. So carbon holds partial positive charge. It is the partial positive charge. It helps for delocalization. Here let us count the pi electron. There are 4 pi bonds, so 8 pi electron. Here charge is cation, so 0 pi electron. Lone pair also not there, so totally 8 pi electron. So it is the 4n system where n equals to 4 multiplied by 2, 8 pi electron. The system is definitely in conjugation because alternative single and double bond. Cation also help for conjugation. Then all are sp2 carbon. So definitely planar. So 4n system conjugated. Planar mean according to the Huckel rule it is an anti-aromatic compound. Then the next example. Here you have 12 aniline system with 3 triple bond, 3 double bond, all are in conjugation. You should find the compound is aromatic or not. Here triple bond is there, so be careful. Triple bond contribute only 2 pi electron, not 4 pi electron. So totally 3 pi bond, 3 triple bond mean 12 pi electron. Charge is not there, so 0. Lone pair is not there, so 0. So totally 12 pi mean, so it is the 4n system with n equals 3. 4 multiplied by 3, 12 pi electron. So the system also in conjugation. So triple bond also a pi electron. It is in conjugation. Triple bond also provide planarity. Since it is linear, it can be planar also. So all are sp2, sp carbon mean planar. So 4n system conjugated. Planar mean according to the Huckel rule it is an anti-aromatic compound. Then the next example. Here you have cyclopropene with anion. You should find the compound is aromatic or not. Here you have anion, so careful with the calculation. First we calculate the pi electron. Here 1 pi bond is there, so 2 pi electron. 1 negative charge is there, it can contribute 2 pi electron. Lone pair is not there, so 0 pi electron. So totally 4 pi electron mean it is the 4n system where n equals 1. The system is definitely conjugated because pi bond and anion can be in conjugation. Anion help for the conjugation. All are sp2 carbon, so the compound is planar. So 4n system conjugated. Planar mean according to the Huckel rule it is an anti-aromatic compound. Then the next example. Here you have benzene fused with cyclohexene with 1,4-diketone. You should find the given compound is aromatic or not. The question is tricky. The carbon with partial positive charge, so it can help for the conjugation. By looking at the plain side, you may commit a mistake. Here partial positive charge provide the conjugation. So the compound is completely conjugated system. Let us count the pi electron. Totally 4 pi bond. So 8 pi electron. Charge is 2 delta positive. It don't contribute anything. So 0. Lone pair is not there. So 0. So totally 8 pi electron. It is the 4n system with n equals to 4 multiplied by 2, 8 pi electron. The system is conjugated because partial positive charge provides conjugation and all are sp2 carbon, so definitely planar. So 4n system conjugated. Planar mean according to the Huckel rule, it is an anti-aromatic compound. Then the final example. Here you have cyclooctatetraene, 8 carbon with 4 double bond. You should find the given compound is aromatic or not. By looking at the blind side, you might commit a mistake. It is the non-planar compound. If you draw real structure, it is with dub shape, non-planar system. If you count the pi electron, it has 4 pi bonds, so 8 pi electrons. Charge is not there, so 0 pi electron. Lone pair is not there, so 0 pi electron. So totally 8 pi electron. So it is the 4n system where n equals to 4 multiplied by 2, 8 pi electron. So it is clearly a 4n system, but conjugation is not there since the compound is not planar. So planarity is not there, conjugation also not there, mean it is non-aromatic compound. It is given as exception. You should not commit mistake as anti-aromatic compound. The cyclooctatetraene is non-aromatic compound. So let us summarize what we learned. Here we see in the library of 4n system, that is anti-aromatic compound. Simple to memorize because all are having 4n electron system, multiples of 4. So careful with charges, triple bond and empty p orbital. You should save this for future reference. It will help you to solve the problems yourself. So what you learn from here, you should start from counting the pi electron. Double bond mean 2 pi electron. Negative charge mean 2 pi electron. Lone pair also mean 2 pi electron. But you should know lone pair participate in conjugation or not. And positive charge 0 pi electron. Then check whether it is 4n series or not. Simply the multiples of 4. And you should know the fact that triple bond only contribute 2 pi electron, and the exceptions include the empty p orbital can act as a cation and sp3 carbon inside the system become the bridge, will move out of the plane as a bridge, provide the conjugation, and more importantly, cyclooctatetraene is non-planar compound with dub shape.